Hi everyone. Guten Tag. I will be speaking about the topic enabling smooth communication between JavaScript and Dart. So the JavaScript logo on the left hand side of your screen and Dart on the right hand side of the screen. So willkommen. Ich bin Aseem Wangoo. So I'm just learning few. I learned 2-3 German words during my time I'm here, 2-3 days. So I am founder of Flutter with Flutter. So this is basically a Flutter blog where I share my experiences in Flutter regarding the different aspects which I have explored till now. I'm an engineer at Shopback, which is a loyalty platform in Southeast Asia. I'm a blogger and tech tuber and a tech writer at Flutter Community. It's a Medium community. Okay, so the agenda for this talk, which I will be sharing with and I will be going with you all together is we will be going through about introduction for Dart and Flutter. So just brief 10,000 feet overview. The next, we will be looking into the Dart compiler as an overview, different types of aspects of the compiler, the Dart native and web. And then we will be going into the actual topic, which is the JS interoperability in Dart. And finally, some interesting use cases. Cool. So Dart. Dart is a client-optimized language for running fast apps on any platform. This is how a simple Dart program looks like. So every Dart program enters or begins with a void main, and whatever is in the void main is the lifetime of the Dart program. So in this case, it's the print hello world. So that means this program will execute this statement itself and complete it. Next, about Flutter. So it's as everyone's here for FlutterCon, so no need for this slide actually, but it's fine. It's a beautiful, fast, productive, and open UI toolkit, which you can create apps for any screen. And for more details, this is the flutter.dev website link. Flutter basically aims for applications that we want to create beautiful applications. We want to create fast applications which should run on 60 FPS. We want the developer lifecycle to be as productive as possible using the Flutter framework. So I can speak with confidence that whosoever has tried Flutter here, so can vouch for this that, hey, like I can feel very productive or you can feel very productive when you're using Flutter. Then it's portable. We are able to create apps using RISC-V, web, embedded, iOS, desktop, X, Y, Z, whatever platform comes up. And finally, it's open, so you can have access to the Dart and Flutter source code forever. Yep. So now let me set the expectations for this talk. This talk will be like a tip of the iceberg, but the actual concept about the interoperability is very huge and not to be covered in 40 minutes. Cool. So before we jump into the main topic, let's first come into a common ground. We will start with an overview for Dart compiler. So this Dart compiler allows us to run apps for native, for running machines on native platforms. For instance, the apps which target the mobile and desktop devices, as well as this compiler allows us to also target web platform, meaning the apps which are designed to run on JavaScript, because web understands JavaScript as of now. Cool. So this Dart compiler, there is a development workflow for the Dart native, as well as there is a production workflow for Dart native and Dart web. So this diagram can see, and this diagram will be followed in 2-3 slides more. So on the left-hand side, you can see the Dart native, which is being targeted by Dart compiler for like ARM32, 64, x86. And then there is this Dart web, which is currently targeted by JavaScript. Cool. So this Dart native basically has two workflows in itself. So for instance, we have the development workflow and then we have the production workflow. Whenever we want to create apps during our development, we don't want the optimizations. We want just faster iterations. We want like the hot reload to work or the hot restart. Anyways, hot restart works, but other goodies like the tooling, the dev tools. So the Dart native compiler allows us to give that flexibility during the development time. And for instance, this compiler, which is called as JIT, just-in-time compiler, allows us with those goodies during the development. Then let's go into the other side, which is the Dart native for production. Whenever we want to run apps, or whenever our apps are ready to go into the App Store or Play Store, or let's say our code is ready to be deployed to backend, we want those optimizations, those garbage collections, those dead code eliminations and whatnot. So for that, we have this AOT, which is the ahead of time compiler. Using this type of mode, which is only available during when we run the apps in build. So we have our consistent launch start time, we have a short startup time, and we get those optimizations which a production app should have. Cool. So till now, we were seeing about the Dart compiler as an overview. Then we saw about Dart native, which is for the apps targeting web. And now let's talk about web. Cool. Another same diagram again. So for Dart web also, we have two types of workflows. The first is the development workflow, and the second is the production workflow, which is the same which we saw for Dart native. During the development also, we don't need any like optimizations. We just want the code that hello world to change to hello world X or Y something. So we get those benefits using the incremental development compiler, which comes out from this Dart compiler for web to Dart web. And then when we want to release our we want to release our source code to the browser, we want those goodies, which, for instance, those optimizations, whenever we have our code that needs to be converted to JavaScript, because browsers understand JavaScript. So, and the Dart2JS compilers or the production compilers help us in achieving those eliminations, and which allows us to run a perfect JavaScript code in the web, all thanks to the Dart web production workflow. Cool. And so now till now we were covering the basic common ground about Dart compiler. So now let the real talk start. JavaScript interoperability in Dart. So currently, Dart web enables us to run Dart code on web platform using a package. It's called as JS. The package itself is called JS package. There are some packages which are already using this package JS. So for instance, the SQLite, the Sass. There are others as well, but just these ones are, I thought to put it. So if we talk about this package JS, it allows us to call the JavaScript APIs from the Dart side or the Dart code from the JavaScript side. And on the right-hand side, you can see the package name and what is its current version, which is 0.6.7. In this package, this allows us to provide some annotations or functions which specifies how that interoperability should work. And this package supports two types of interop, the static interop and the dynamic interop. So not everything in this world is perfect, so is with this package. There are some constraints about how to use this package. So the first is the Dart SDK should be 2.19 and above. And the second is the package itself should be greater than 0.6.6, or it can be that as well. Cool. So this package supports two types of interops, the static interop and the dynamic interop. This is a comparison between these two types of interops. The static interop, which is on the left-hand side, it's a next generation of JS interop, meaning the Dart team is recommending this for us, for developers or contributors. This static interop has performance benefits over the dynamic interop. And dynamic interop was supported till now, but that team has made it very clear that we would be going with the static interop. And we will be covering why is this happening. And later on, we will also see some demos on the way. It will not be all talk. So now this static interop, let's give an overview about this. So this involves the static interop allows us to have a predefined and a static interface, which allows us to communicate between JS and Dart. So when I say predefined, I mean like we have a straight path, or we have these guidelines that, hey, if you want to do this, go by this way or go by X way, Y way. But those ways are defined for us in the static interop. It allows us to get the interop in compile time, which is very important because most of the time the developers are programming and we compile to see if our code has errors or not. It's not like we run it we ship it and then we try to debug. So with static interop, we get this one of the most important things, which is this compile time interoperability. This in its sense also says that, hey, I am giving you type safety as well because I am giving you errors at compile time only. Yeah. Cool. So the other side of the interop, which is the dynamic interop, this allows, as the name suggests, a flexible way to have this communication. When I say flexible, I mean like you can create your own path or you can follow the existing ones. So it's not so strict. That's why it's flexible. And this interop is established at runtime. So meaning we may or may not get those errors when we want to see them during our development workflow. And since this interop is established at runtime, this type of interop is more flexible. And it's more adaptable, but yeah, the trade-off is there is no type safety or the goodies which we want from the compile time checking. So this is one of the demos which was presented during the Flutter conference earlier this year, I think. So in this demo, this is using element embedding. Under the hood, it is using JavaScript Dart interop. So we have the screen, we increment the left-hand side is the JavaScript and the right-hand side is the Flutter web app. So if you see the person I am the person only. So I'm passing some commands from the left-hand side, which is the JavaScript, and these are getting reflected on the right-hand side, which is the Flutter web app. So I'm incrementing, I'm putting the shadow gets reflected in the Flutter web app, and I'm changing the device from static to a handheld device. And I'm printing hello Berlin. Yeah, cool. So since should be very hint should be already provided to all of you why we are going with static interop. So there are some benefits about that. The first is idiomaticity, meaning like there are some guidelines or conventions or patterns that, hey, you should do this via this, you should do that via that. The idiomatic code is readable, maintainable. You can express it to other developers as well, between yourselves as well. And yes, another benefit is performance. So since we already have those eliminations or we have those compile time checks, the code is more performant. There is no there's the efficient code in terms of speed, like the way in which that code is being executed during whenever you want to run it, it's performant and takes less resources. And yes, type soundness, which is one of the other features of this part, which is like, hey, let's say I was Boolean when you were starting me, and after some time I become string when you are seeing me in the runtime. So that's not the case in static interop. The type checking is there. What is string in the beginning remains string at the end. So yeah, what you see is what you get. And the last important thing is WASM compatibility. So if anyone is following Flutter Web closely, so the Dart team is going all in on WebAssembly. This year they announced the full hey, we are going all in on WebAssembly, and that WebAssembly needs a guidelines or a static way or static interop. That's why the team is recommending this as well. Cool. So now I will be showing you another demo about this interoperability. Okay. Okay, so before I click on this play button at the down, on the left-hand side, you have the Flutter web app. So this has the animation. I have not started it yet, but just giving the context. So on the right-hand side, you have the JavaScript to Dart. So this is the JavaScript section on the right-hand side, and the left-hand side is the Flutter web app. So now the animation runs, the car is running, and if you can see, there is a floating action button on the bottom right. So that is turned to it's already playing, and the text on the right-hand side is stop car. That means you want to stop car, then you need to press this button. But as of now, it's running. So yeah, I'm showing that, hey, this is JS to Dart and Dart to JS. Now I will be pausing this. So this is within the Flutter web app. I paused the animation, but yeah, this is very simple. I paused it within the web app itself, so it's not a big deal. But if you see on the right-hand side, the stop car changed to drive car. I paused the animation on the left-hand side, which is the Flutter web app, but the text changed in the right-hand side, which is the JavaScript. And let's continue further. And now I see the drive car, yeah. So I click on play again, I think, yeah. I click on play, the text again changes to the stop car, yeah, again. And now I will be, yeah. So here, what I did was, I went to JavaScript side and I pushed a command that, hey, I want to stop the car now. So this time I put the command from JavaScript side and it went to the Flutter side, and it stopped the animation. It started the animation, and as well as the floating action button also changed. So as I continue the same, this is being the intro. This is a small part of interop, one level, a basic use case, how we can use this interop. I hope it was good enough. Cool. So let's move forward. And let's deep dive into the static interop, because that is how we will be achieving this interoperability. This static interop is coming from the package.js, and how we use this is using this annotation static interop introduced from 0.6 onwards. The classes which have this annotation don't support dynamic interop or dynamic invocations. So that is one of the good things. And this way, we want to make backends consistent. So meaning a thing which is string when we were doing our development cannot change to Boolean, so that this makes the backends consistent, which is very important. This is done basically by the compiler itself. And since the package is having 0.6.6, so it internally also enriches the compiler, which would know these type of fixes. Or the compiler knows that, hey, okay, I'm using this version. So yeah, that's the case. This is how we call Dart function from JS. On the right-hand side, so we can see the snippet. And if I can take your eyes to the bottom part of the snippet, which is the void main. And as we know that void main is the entry point of any Dart program. In this, we are passing it allow interop, which is if we want to call interoperability, we need to have this allow interop function. This is coming from the package.js, which is the first line in this slide. Yes, so in this allow interop, we are calling a sum Dart function, And this sum dart function is just simply printing hello from Dart. Cool. And if we want to do the other way around from JavaScript to Dart, we just need to have this annotation at JS and then pass in the function name. And that function name is the same which you can see on the 1, 2, 3, 4th point. Should also be the function name. If we were looking at the source code, this is very tedious. The previous snippet, it's not easy. So these were some observations which the community gave to this package. It's too focused on JavaScript to Dart, not from Dart to JavaScript, because in the previous slide, I didn't mention about Dart to JavaScript. And this allow interop also, you cannot remember always that, hey, I want to make some interoperability, so I need to always call this allow interop. That's not good. And in case if your class is very huge, you need to put that allow interop on all the individual members or instances. So with this, can we do better? And yes, we can. There were some improvements made in this package. So the improvement which I'm showing here is the create Dart export. So you no longer need to call allow interop. We can just use this create Dart in export, which does all the it transforms the JS object to Dart and the literal whatever is needed on the JavaScript side for that code base to run, or the code or the function to run. But yes, you still have to make that annotation at JS export on a class which you want to be called from JavaScript or Dart. And in the bottom, we can see in the void main, which is the entry point, you are instantiating an instance of this counter class, which is annotated with this at JS export annotation. So this can be called from Dart.js or vice versa. And next, using this create Dart export, we say that, hey, I want to call this instance, which is also marked with this at JS annotation as JS counter, and that JS counter is also having that annotation at JS. Cool. So the summary is use create Dart export, which is now in version 6067. This create Dart export takes care of the transformations, and you can use the goodies which come out from this create Dart export. So with this, I will be now going to the other side of the talk, which is I will be showing some use cases. The web animations we saw already. Now I will be showing the counter app, which is a very simple app, and then dynamic web app navigation. And third, if anyone wants to guess, or I can give a hint as well. So if you guys have seen the Google I/O, what was the most famous word after the Google I/O which went live? So yes, that's correct. So the third, we will be covering about something you all know by now. So, but before that, I will be taking you with this demo. So in this case, on the top section, basically, it's the JavaScript. Sorry, it's the GIF basically. So in the bottom, it's the Flutter web counter app. Okay, so basically, I'm incrementing the value from JavaScript side. That value gets incremented in the Flutter side. Yeah, I press the increment button, the value gets here, and I hide show, but that is within the JavaScript, no big deal. But when I click from the plus button in the Flutter website, the value gets incremented in the JavaScript side. And I am able to dynamically navigate that button click from, for instance, I am saying that, hey, you should go to Google or you should go to Flutter in this case. So it's going to Flutter. If I click on, okay, it's a GIF. So if I would have clicked to Google, the button would have gone to Google. So this I am doing via JavaScript Dart. If this GIF plays so fast, I can show, but never mind. Cool, yeah, so it went to Flutter, which is by default. And then if I click on Google, it should go to google.com. Yep. Cool. And now we will be doing this, which is integrating ChatGPT in Flutter, because AI everywhere. Yep. So basically, there are only 3 steps for this. Internally, these steps are a bit long. So the first step is we need to create the ChatGPT server locally. The second is we need to create the ChatGPT UI. And the third is we need to pass in the prompts, whatever the user says to the ChatGPT, which will be done from Dart to JS thanks to this interoperability. Oh, cool. So for the first step, and by the way, you get us, right? So for the first step, we have this normal Node.js app where we are creating a server.js file, which you can see on the right-hand side. So yes, we need to install some dependencies. So for instance, it's OpenAI, API, and Express, because we want to create a server locally. Then yes, we need to have that key, OpenAI key, because we need to interact with those guys. Second, this is how the interaction, the query would go from our side to their side. So we will be calling this create completion, which is coming from that OpenAI object. There are 3 parameters: model, which is the text DaVinci at the time when I was programming. This is GPT-3, not GPT-4. The prompt is the user query. And the third is max tokens, which the models can generate, which is 3,000. The response we get back is in the form of a bot. Like we specify that, hey, get us back the response in, send it in the JSON inside a property called as bot. Cool. So if this is done correctly, we should run our server using npm run server. This starts on 5001. And if we curl, we are sending a prompt, hello, how are you? And the GPT server responds us, oh, okay, no worries. So we run the server. It starts on 5001. We want to curl to test this. We are saying, hello, how are you? The GPT server says, doing well, thank you, how about you? So this is JavaScript server running locally. The next part is how to create ChatGPT UI. So for that, we will be creating a Flutter web app. Only 2 Dart files needed, the main.dart and gpt.dart. Next, if anyone has created Flutter web project, so we come with a by default web folder, which in this case we modify a bit. We place some assets, we place some CSS, which should be looking like ChatGPT UI. And then we have this main important file, which is the JS interop file, which will be taking care of sending over our prompts to GPT. So in the UI, which is the Flutter side, we will be creating this simple text controller in which we would be entering our query. And since we need those prompts, we would also be managing that using a text controller. And yes, another thing is, this is not a normal Flutter web app. So we need to have something customized. When I say customized, I mean like I need to show this input on the left-hand side and the ChatGPT UI on the right-hand side, so that it should feel interactive, right? Whatever I'm typing, when I press enter, it should go to the GPT UI. These both should be coming on the side by side, which you can see now. So on the left-hand side, this is our Flutter app. I put in the query. I will press enter, or I can press this floating action button. Then something will render and show on the right-hand side, which is the ChatGPT UI. Cool. So as we talked about, so this is how we need to customize so that we can put it back to back, side to side. This is done using a JavaScript API, which is called Flutter Loader, provided by Flutter.js. This initialization, which is by default, basically, this is by default what we get out of Flutter web project. We have the Flutter Loader JS API. The initialization process has 3 steps. The first is we fetch the main.js script, which internally initializes the basic setup. Then we initialize the Flutter web engine. And at the last, we run the Flutter web app. And you don't have to do this. This is automatically taken care by Flutter team. This is what we get. And this is supporting 2.10 and earlier. Yeah. This is how I was talking about. On the first arrow, you can see the Flutter.js package, or not the package, the script file. Next, this is which is the other script tag, which is the more detailed one. This is like we call the load entry point, we get that callback, which is the on entry point loaded callback. Then we set the runtime configuration using the engine initializer on the on entry point loaded. And finally, we run the app using .run app. This is all by default. You don't have to do anything this, but we need to tweak this. Yeah. And this is how we tweak this. The code is shorter. So the first line is, again, we are importing the JS interop, which is the file which we created in the first step. Second is we need to we need to basically embed that HTML thing, which is the ChatGPT UI, into our Flutter web project, which was on the left-hand side on the text controller. So that is done using something called as host element. And that target is basically a simple, in the HTML world, we have those hash, the div IDs, or this is basically a div ID, nothing else. And yes, we start that Flutter web engine using the run app. So this was, we continue into the second step. We come to the Flutter side. In the GPT, we have two files, the gpt.dart and main.dart. The gpt.dart, basically, we create a stateful widget, and each stateful widget has a stateful object, basically. And that object, we have to export it to the JavaScript side using that annotation, JavaScript JS export. So next is, as we saw in the overview, we would call create.export. And that create.export, what we do is we pass this. And this is basically the current context of the code, which in this case is that state object itself. And this is done basically by importing the JS and the JSUtil package. Then we need to set some properties wherein we want to pass the app state object from Dart side to the JavaScript side so that it can handle. We do it using the set property, and we also call in the method the state set, basically. So basically the state set would be used or would be defined in the JS interop file, because we need to pass some data, if we want, from JS to Dart as well. The HTML side is fairly simple. So so this target, which is the host element, we have this hashtag Flutter_target. So that is basically defined here. So we have two divs. The left-hand side div is the parent, which would be comprising of the Flutter web. And on the right-hand side was the ChatGPT UI enclosed in the Flutter target. And internally we would use some fields as well, like app, chat container. Simple HTML, nothing else. On the JavaScript side, basically, this is all happening in the JS interop file. We have to access those elements, and then finally, we need to have this function for differentiating between user prompt and bot. So when I say this, like if you can see, when we type hello, the stripe looks different, and what the GPT responds us, it should look different. That is handled by the JavaScript functions. And so till now, we have, let's say if we type hello, we get this on the left or top. And then there is nothing because we don't have that server integrated in our code, which is the final step. So this is how we pass in the prompts from the Flutter side to the JavaScript side. And then, this is how we get the handle submit, which is the action on which the person would click on the enter button or the floating action button. The query would pass from the Flutter side to the Dart side. And finally, in order to this to work, we need to have those event listeners attached. And yes, this is the last part wherein we say that, hey, okay, everything is with me. Now just put this server and just give me the output. And what happens? Oh shit. Time for real demo. So I run the server. I run the app. So the server is running on 5001. I am now running the Flutter web project. Takes time. Okay, it's up. So let me put the query. Let's say hello world. I'm pressing enter. So it's say like, hey, hello, it's nice to meet you. How are you doing today? And yeah, this way of presenting text is also handled in the JavaScript side. Those are some custom functions which I haven't shown you guys. So we can, on the left hand side, we can see the history, whatever we are talking. We are typing weather today. So yeah, so weather, oh man, yes, that's right. Cool. So yeah, this is the real demo. And with this, I will switch back and say Danka.